Right, hi everyone. These are the notes for the similarity topic in the Nat 5 course. The similarity topic is quite a broad topic in Nat 5, but the methods and the processes are very, very similar. And if you were to look up past paper questions when we come to those, generally it's asking the same sort of skill every time, okay? So the first step is to introduce what similarity actually means and how to go through some of the processes. So in maths, we say that two shapes are similar if they are exactly the same shape but different sizes. Okay, so you can see the two shapes in the examples below. They are exactly the same, it's just one is smaller than the other or one has been enlarged from the other. To get between these two shapes, we have to either enlarge or reduce the original shape, and we do this through a scale factor. Every single side, when we're looking at lengths, has to be multiplied by the same scale factor. So if I have a box, say that was that box there, and this was 10 and 5, whatever I multiplied the 10 by, I would also have to multiply the 5 by. So that scale factor has to multiply every single side. Since this one's a box, that's 5 and 10 as well, which means they would multiply by the same number. Okay, so the formula for scale factor, for length scale factor, in fact, we'll look at area and volume later on, is to first of all, so we calculate the scale factor by taking the length in the new shape divided by the length in the old shape. So it's new over old. Okay, new over old every time. Okay, to find the missing length then, we multiply the scale factor, which is a fraction in some cases, by the old length. So let's see how that applies to the questions down below. So the first step then is to find the scale factor, so SF, and that equals new over old. So what do we have in this case? We have two shapes. This is the new one. So the one that we want to find something out about is the new one, and the old one is the one that we know everything about. So we need to find two matching lengths so that we can use them to mean new and old. So in this case, I'm going to use the 10 and the 25. The reason I'm using those two is because I have both of the lengths here. If I was to try and use the x and the 15, I wouldn't create a number from that. So it wouldn't give me a number or a fraction to be able to multiply by. So in this case, new is 10 and old is 25. Generally, you'll have a calculator for these questions, but just in case you don't, and I mean, you won't need one just now, we simplify this fraction. So 10 over 25, divide top and bottom by 5, and we end up with 2 over 5. The second step, so that's step 1, is to find the scale factor. You're always given 1 mark for that. So the length, in this case it is x, is equal to 2 over 5 times by the old length. Now as you can see here, the x matches up with the 15. So it's 2 over 5 times 15. Now in that case we have, that could be 2/5 of 15, or we could multiply the fractions together, make it 2 over 5 times 15 over 1. So 30 over 5, in which case x is 6 centimetres. Okay, next one. We have got two triangles here this time. The first step is to find the scale factor, and we find that by new over old. So what do we have here? We have got 4 and 8 will be the two numbers that we use to find the scale factor, because those are the two numbers that we know. Therefore, we can combine them into the fraction to make a number for the scale factor. The new shape is the one that we have something missing from, and the old shape is the one that we started with. So the new shape here has a length of 8. The old shape has a length of 4, so 8 divided by 4, and our scale factor is 2. We take that scale factor of 2 and we times it by the length that matches up to the x. X is the height of the triangle, so the height of the first triangle is 3. 2 times 3 then, giving me 6 centimetres again. Okay, a coincidence that this one is both 6. Similarly, we can take lengths with these triangles here. Now this is more of an exam type question for finding the length based on similarity work. Okay, so 2 triangles with the same 3 angles that are the same size are similar. It often happens when we have triangles included within parallel lines. Okay, if you're not told that these parallel lines are here, then you cannot be sure that the triangles are going to be similar. And what I'm going to do first here is to draw out each of these triangles in a slightly different way. For the first one, I am going to take the smaller triangle up the top and draw that here. That's the one with 16 millimeters on the base and X up the side. The other triangle, so we need 2 shapes in order to calculate similarity. The other triangle is the larger one, which includes a 40 millimeters down the bottom and a whole 36 millimeters up the side. Now, in order to complete this question, I do the same as I did on the previous slide. The scale factor is new over old. In the new shape, we have 16. So we're looking for the lengths that match up. That's why we have to rotate these triangles so we can match up properly what the length should be. So 16 is in the new shape because that's what we want to find. 40 on the bottom in the old shape. And we have to then simplify this fraction. It's easier to simplify the fraction just in case we don't have a calculator. So we can divide both of these by 8 and we will get 2 over 5. The next step here is to calculate x. So that is 2 over 5, which is our scale factor, times by the 36. So it's the old length that is already given to us in the question. So you can see here that the 36 and the x match up with one another, which is how I know to multiply it by the 36. And that will give me 14.4. Okay, units in there, if I squeeze them in, will be millimetres. The next question here, I am going to do something similar. So first step is to write out these 2 triangles so that they're both facing the same way. So this bottom triangle here, I am going to take and just leave it as it is. 3 metres on that side, 4.5 metres on that side. And the next one then, I am going to flip this triangle round so that the parallel line becomes the base. Now in this case, x is going to be on the left hand side and 3.6 will be on the right hand side. I've flipped the triangle right the way around, I've rotated it all the way around to create that. Okay, so I've got to now find the scale factor. This is the new shape, because that's the one that something is missing from. So new over old. And we see that we have 3.6 and 3 here to use. So 3.6, divide that by 3. And the good thing here is we end up with 1.2. So decimal, fraction, whole number, any of those can represent your scale factor. Okay, so we need to take that and times it by the side that relates to x. So x then is the scale factor, which is 1.2, times by 4.5. I'm just going to pop that into the calculator to get the answer for it. So we'll end up with 5.4 metres in this case. Okay, the reason I have to times by the 4.5 is because that's the side that matches up with the x in these triangles. So, if you're going to then complete some questions on these, you will find questions on length and similarity in the Unit 4 book, page 18 and 19. Okay. During the lesson, I'll be giving out specific instructions of what pages to do. But if you've missed a lesson and you're looking to do some extra work possibly, that's where you'll find those questions. Okay. Moving on, we can also look at our similarity based on area. So in this case, we follow the same process, but the only thing that has to change, as you'll notice in here, we have got to square our scale factor. Okay, so we still new and old. All right, we take the length of the new shape, the length of the old shape, we still divide them, but we have to square that then instead. And if you think about area, so area is measured in centimetres squared, in metres squared, in millimetres squared, and so on. So that makes sense. We're squaring it. We are going up a level. Okay. So that is our process for similar areas, and we'll see a couple of examples now. So this is example 3 from the notes. I'm going to start this now. So scale factor is new over old. The shape that we don't know something about is always the new one, so that's the one on the right hand side here, and the one on the left is the old. The new shape then here is, what do we have? So we've got 7 and we've got 14. We have both numbers for those, which means we can use those two in our fraction. So new is 7, old is 14. 7 over 14 can simplify to a half. Generally, you'll be given a calculator for these ones, so what we'll do is we'll change that into a decimal of 0.5 so that we can perform the calculations a bit easier in our calculator. Now, to find the area then, that's what we're looking to calculate. We have to take the scale factor. We are working with area, so we have to square the scale factor and multiply it by the old area. So that is 308. Now, this process can go in your calculator, 0.5 squared multiplied by 308. And when we do that, we get 77. Pop your units on the end, and that tells us that the area of the smaller half circle is 77 metres squared. We're not asked to calculate that area, we're not asked to do any arcs and sectors, just to use similarity for this one. Okay, next is very similar. So we have to first find our scale factor, and we use the lengths that we're given. So the first shape here on the left hand side will be the old shape, since we know everything about that. The new shape, because we don't know what the area is. So new over old to find the scale factor, 15 over 6. And we can change that to a decimal. 15 divided by 6 will give us 2.5. That's part 1 done, and you would get 1 mark for this. And then the next part is to calculate the area. So we take our scale factor. We are working with area, so we have to square it and times it by the old area. So 22.5 is what we have to multiply it by. Again, we can go to our calculator for this. 2.5 squared times 22.5 gives us 140.625. And that is centimetres squared. Okay. Now, questions like this you will find on in the Unit 4 booklet again. So just write these here. Unit 4, you will find on page 20 and page 21. Again, I'll give you specific questions to do when we do this in class, but if you're looking for extra or you're watching this video later on, those are where you'll find area questions to complete. Moving on. Okay, so length, area, what comes next? Think about our shapes. We look at 3D shapes, which means we're looking at volume. Now in this case, it's very, very similar yet again. The only difference is when we come to find our scale factor, we have to cube our new over old length. Again, if we think about what we measure volume in, centimetres cubed, metres cubed, millimetres cubed, so that process makes sense, but also we are going up a dimension, which means we have to add in an extra layer. We have to account for that going up a dimension. Okay, so a couple of questions on this. Example 5, and again it starts off the same as before. So the scale factor is new over old. And in this question we've got to really read the question to decide what's going on here. So we're told that coffee cups are sold in mathematically similar sizes, which is good because that means we can use this process. The large cup has a base of 10, so that's this one here, and holds 625 millilitres. So that's 625 millilitres for that one. A medium cup has a base of 8. We want to find the volume of the medium cup. We don't know that volume there. The one we don't know is new. So the new one's on the left here, and the old one is the larger one. So we're looking for the lengths of both of these cups, and it is new, which is 8, over old, which is 10. If we change that to decimal, it's a lot easier to put into our calculator. So we'll make that 0.8. And the last thing to do is to do our calculation to find the volume. So we take our scale factor, 0.8, we cube it, power of 3, and we times it by the old volume, 625. So again, over to the calculator for this one, 0.8 cubed times 625 gives us 320. Our units for volume in this case are millilitres. Okay, one more. And this one we're not given a diagram, so I'm going to draw out the diagram based on what I'm told in the question. So a shampoo says that manufacturer says that they have got 2 bottles, okay, and the prices are according to their volume, okay. So the question here includes the word volume, so that might be something that we are considering, okay. We have this, they sell the regular size bottle, which is a height of 14 centimetres. So let's try and draw a little bottle shape here. That will do. And that's height is 14 centimetres. That's the regular one. And a supersized one, so it's a larger one, which has a height of, what are we told, 28 centimetres. Now, this first one, the original one, has a cost of £3.20. Now, the reason that we are going to complete the volume calculations on this rather than just a length calculation is because of this first statement here. So the price is according to its volume. So not according to how tall it is, but according to its volume. Which means in similarity terms, we are going to need to use the volume scale factor in order to find out the price of the supersized bottle. So, let's start this off. Scale factor, new over old. I don't know what the supersized one is, so that is the new one. The old one then is the one that I know everything about. Both lengths I know, so it's 28 over 14 here. We'll create the scale factor. If we divide those, we get 2. Therefore, the cost of the supersized one is relating to its volume, so it's the scale factor cubed, multiplied by the cost of the smaller bottle, okay? Or, in this case, the regular bottle. So again, if we pop that into our calculator, the cost of the supersized one is £25.60. Okay. Now, this is the end of the volume one, and we will find questions on that in the Unit 4 booklet, page 22 and page 23. From there then, we can move on. Next, we are going to do something called reversing the similarity. So rather than start with the length this time, we are going to start with either the area or the volume. Now, essentially what we're doing is we're working backwards. We are given the area and we're trying to find the length. If you remember to previously, when finding the area, we squared. Think about working backwards. We are going to do the opposite, which in this case will be square root. So, to start us off here, we take the scale factor as before, but in this case, as we can see, we have got both areas that are given to us. We always need to be careful with what we are actually given in the question. Now, the larger one here is the new one, and the smaller one is the old one. So, new over old will give us 36 over 4, which will equal 9. Now, the reason we have to do this next step is because we're working backwards, okay? So we're given the area, we're trying to get backwards to a length, so we're trying to get rid of a dimension, so we have to square root. So therefore x is equal to the square root of 9 multiplied by the old length, which is 3.5. Now if we pop that into our calculator, so square root of 9 is 3, and we can multiply that by the 3.5. We'll end up with 10.5. So 10.5 centimetres is the length of the second shape down the bottom there where the X is. We do a similar process when given both volumes. So we've got 2 trash cans here, both with a volume given. We want to try and reduce the dimensions down, so we're given the height. Now if you remember volume, we cubed. So to go back the way, we are going to have to cube root. We still find the scale factor the same way, new over old. We're just this time working with the volumes. Now the new one here is the smaller one, and the old one is the larger one. 5 litres is contained within the smaller one, 40 is contained within the larger one. If we change this to a decimal, we will get 0.125. And in order to find the height then, so it's a h this time we're using, it is the cube root. So the opposite of cubing is to go for the cube root. And it's a cube root of 0.125. We times that then by the height of the larger one, which is 45. Now the cube root of 0.125, it has been chosen specifically so that it will give you the number 2. Sorry, not 2, 0.5. We can then times that by 45 in order to get the height, and the height then of the smaller trash can is 22.5 centimetres. Okay, the reason we're multiplying by the 45 again is because the 45 relates to the h, it's the height of the larger one. Now, for these ones, you will find them dotted throughout the past paper section. Okay, so we won't spend too much time on these. What you will get instead, probably in class, is a worksheet on this, okay, rather than using the booklets for these ones. Next, however, we can move on to the past paper questions, and this is the first one that we've got to do here. As you can see, we've got some triangles, but a key word there to pick out is that we're looking at area of some of the triangles here. So the first step is to draw out these two triangles, so we're pretty sure what we're working with. That will be the larger one here, so with 30. I'm just going to put out also the sides of it, so P, R and S for the larger one, and the smaller one is Q, T and R, with 24 as my length up the side. So what else am I told in the question? Area of QRT is the second smaller triangle, that is 400 centimetres squared. I am asked then to calculate, come on, there we go, the area of the blue section. Now you can't see a blue section here because it's in black and white, but the blue section, if this was in colour and in a test, is the section inside here. Okay, so the first thing to do in this question, it may not be so obvious, but we are working with similarity. We know a length and an area of one triangle, we know a length of the other triangle, so let's try and find the area of it. Okay, there's a good few steps to do here. This will be the first one, find the area of the larger triangle. New over old is what we have to do. New one is the one that we don't know enough about, so that's the 30 and the 24 on the bottom there. Change that then into a decimal. Gives us 1.25. To find the area of the larger triangle, so it's area of PRS, that's what I'm finding just now, 1.25 squared times the area of the smaller one, 400. Pop that into the calculator and we get 625 centimetres squared. We are not finished yet. That gave us this whole area of the larger triangle. We know that the area of the smaller triangle is 400. So in order to get the blue section, which again, apologies, you can't see that in the diagram, but it's the section that is the big triangle, take away the smaller triangle. So it's this bit here that we're trying to find. Now when we subtract that, it'll give us 225 centimetres squared will be our final answer. So as you can see with this one, it's a question that's kind of trickier but disguised within something else. So it's an area similarity question just with an extra bit to do at the end. Okay, and next question here. There's two parts to this, so A is on this page and B is on the next page. Show that the two cartoons are not mathematically similar. So we know that if these are mathematically similar, then we will have all of the conditions met. Okay, we are working with volume here, so we have to try and consider the volume scale factor. So we can go either way this time. I'm going to say that the smaller one is the old and the larger one is the new. And what I'm going to do is start off by saying, so the scale factor this time would be new over old, and that would be 24 over 16. Change that to a decimal, so what I'm using here is the two lengths, the 16 and the 24. I'm using the two lengths to try and calculate whether the two volumes match up after I've done all the calculations. So we're starting off with 24 divided 16 to get a decimal of 1.5. So therefore, the volume of the new one should be 1.5 cubed times the volume of the old, the 576. So if we pop that into the calculator, see what we end up with for that. And we end up with 1944. Now, that's good in this case because it does not match up with the 1125 that we're given. So, to show that these are not similar, since 1944, 1944, if I can just write that in properly there, does not equal 1125. The cartons are not mathematically similar. Okay, so I've proved that through calculation up the top there. Okay, I've proved that if they were mathematically similar, these calculations would work out. They don't, which means it is not mathematically similar. So this answer that I get does not match up with the one in the question. Now, part B for this question, the larger carton is redesigned so that the two cartons are now mathematically similar. The volume of the redesigned large carton is 15,000 cubic centimetres. Calculate the depth of the redesigned large carton. So what we have here is essentially the same question, two cartons. The first carton has stayed exactly the same. So it's 16 centimetres tall and 576 cubic centimetres in volume. So 16 centimetres tall, 576 in volume. We are told now that the second larger carton is 1500 cubic centimetres, and this will now make these cartons mathematically similar. What we need to work out is how deep or how tall, in this case, the carton is. So this question is us working backwards, like we did in the previous two examples. We start off with the scale factor. We still have to do new over old. The new one is what we want to find, so the new volume is 1500. The old volume is 576. And we can do our calculations in a calculator for that to create a decimal. This gives us a decimal of 2.6041 and so on. Therefore, this is our volume calculation. To find the height, we have got to reduce down our levels. So I have to then take what I have just calculated, cube root it, and times it by the old length. So I'm going to straight cube root this into my calculator as the big long decimal it is, and then times it by the 16. Now that gives me 22.012 and so on. So 22 centimetres is the height of the new curtain. Alright, now these past paper questions can be found in your Unit 4 booklet. You will need to complete them from page, so Unit 4, page 24 until, when you finish, there's quite a few of these to have a look through. So 24 and 25, never mind, not as much as I thought there was, but there will be more given to you as we do these questions in class from past papers. Okay, good luck with the questions. Hopefully you've used this video throughout to try and just catch up with anything, and make sure you're asking questions if you need to. Okay, thank you very much.